Welcome to the 90th video in our series about Unix tools. In this video, I'm going to show you how to compile some Fortran programs. If you were a serious computer scientist, you already know that Fortran was the first high-level computer language that ever got compiled, and that occurred in the late 1950s at IBM. This means that the compiler technology for Fortran has had more than 70 years of development. The Fortran, which was short for formula translation, language was designed for doing mathematics, and today it is still the highest performance language for serious mathematics using hardware math features. Math that's built into the CPU. Did you know that the famous NumPy package for Python has many critical parts written in Fortran? Many chemists, physicists, biologists, engineers, and mathematicians still use Fortran today. After all, there's 70 years of Fortran programs. Probably one of those solves your problem. And if it doesn't, you can grab one and modify it. The GNU compiler collection, which is where GCC and G++ come from, also has gfortran for compiling Fortran programs. Fortran has evolved over those 70 years, and today there are basically three main dialects used. The oldest code is for Fortran 4. And then Fortran 77 was the next major change. There are many minor changes in there, but Fortran 77 is a different style. And then in 1990, Fortran 90 came out, and that's been the basis of all modern Fortran code. There are many, Fortran 90, 95, 2008, all the way up to, I think the last one is 2018. But all the ones after 1990 look about the same. So let's learn how to do this. I've set up three directories. You can see them right here. I've got a Fortran 4, Fortran 77, and I called it Fortran 95 because GNU Fortran doesn't have special Fortran 90 support. That's so old, so they group it and they start with 95. But Fortran 95 is a superset of Fortran 90. Okay, let's go to the oldest style of all, Fortran 4. This was designed in the 1950s for punched cards. So it uses fixed column positions for the source code. And if we take a look at that, you can see, once I turn on some stuff, you can see all these things line up in column 7. Column 1 has things like the C that tells us it's a comment, and a space is actually code. Then the columns 2 through 6 are for the line number, and you use line numbers for things like this format statement, and you would also use them for jump targets if you try to do a for loop or something like that. Fortran 4 is all in uppercase because in the 1950s computers didn't support lowercase letters at all. Everything was in all caps all the time. And another thing that lets you know right away this is Fortran 4 code is it uses these numbers, 12H, and then it has 12 bytes. And 1H and the space is the byte. These are Hollerith strings. Instead of using double quotes, you give a number, an integer number, an H, and then whatever the number said, the next, if it said 12, the next 12 bytes, or if it said 1, the next 1 byte. Here, the next And this looks like hand number, but remember that goes with the 11. So there will be 11 characters here. Hollerith strings. So this is a simple hello world that also prints an integer value, which is 10. That's what the code looks like. And how do you compile it? Because that's really old stuff. Well, I tried to match the spirit. There was no make program when Fortran 4 existed. People did it with JCL or something like that. Basically batch code. So we have build it, which is a shell program. And let's run it. And you can see G-Fortran, I say it's legacy. And for the GNU project, anything before 1995, they count as legacy. And then it has the same option we're used to, -C, which says compile only. We have the source code, which is hello.f. And then we say, and I want you to output, and it generates an object file. Very much like we did with GCC. And then we have to do the link. So we say G-Fortran, and the list of all the object files, we only have one. -O, and the name of the executable, which is going to be hello. And you could do libraries if you had any, but we don't. Let's run it. Hello world and number 10. So the program worked. And you can see how we compiled it. And then I can't do a make clean, so I have cleanit.sh, which you can see right there, a short little shell script. Like all shell scripts, it starts with a hash bang, a space, and then the name of your shell, which we're using bin bash. And then it's got the shell code, which is basically we echo, which is a way to print this message. And we do the rm-f just like we would in a real make file. And so after I run clean it, I'm back to my shell scripts and the Fortran. You don't see much Fortran 4 code anymore, but if you picked up an old textbook, you might see some. Fortran 77, however, there is a lot of Fortran 77 code still in use today in many science departments. Because if it works, they just, why change it? Why rewrite it? If it's working well and you've already debugged it, there's no reason to change it. And so Fortran source code tends to live much longer life than something like Python. In 20 years, Python's been rewritten 3 times, which is why we're on Python 3. And so there you go. Let's get in there. Fortran 95. I'm having trouble. Because I'm in the Fortran 77 already. No, I'm not tired. So here we go. We've got hello.f. What does it look like? It's still using that same fixed column style. Column 1 will have a C. It also has some other symbols you can use for continuation lines. But then from column 2 to column 6 is your line number, and then you've got your code. But you can see we don't have those horrible Hollerith strings anymore. We have a string in single quotes. We can use some lowercase letters inside the string. It's nicer. And how do we do that? Well, by the time 1977 came out, make existed. So I have a make file for this. If we take a look at the make file, it looks just like the C make file, except instead of having CC equal GCC, I've got F77. But otherwise, it looks very similar. If we do a make and we run hello, we get very similar output to our Fortran 4 version, but now we can use lowercase letters and it looks a little bit nicer. But 1977 is still older than most of the people watching this video. And so we need to move on to the Fortran 95 I was trying to get into a minute ago. Okay, here it is. It also has a make file because make is still going strong between 1977 and 1995. And in fact, here we are in 2024, make is still used. So what's the Fortran look like? Wow, it's a whole lot different. You notice that it isn't using line numbers anymore. And instead of having a C in column 1 for the comment, they use a bang or an exclamation point. And this one I've used uppercase letters because a lot of Fortran programmers they still use uppercase because they always did. But you don't have to. And you can see that we don't have a separate format line anymore. Instead, we use this variable, I shouldn't say variable, computed at compile time length string for the format, and we call it form1. And we use print. We don't use write anymore. We use print with form1, and we do an I. So this may look the same as all the others to you, but for Fortran people, this is considerably nicer. The lines can be longer. In the original version, you have to stop at column 72. Any line longer than 72 just gets chopped off. And you can't start until line 7, so the lines have to be very short. And those problems are solved in Fortran 90. But remember, I told you GNU starts with Fortran 95. Anything before that they call legacy. What's the makefile look like? You notice I've changed my standard to Fortran 95, and I've said free form because Fortran 95 can still accept the punched card fixed column style. And so you have to tell G-Fortran, no, I'm using the free form, the new style. And that's an F flag. We had C flags when we did C compiler and CC. But for Fortran, we have FC and F flags. Okay. Otherwise, the makefile looks almost identical to the C. The only thing is we have FC instead of CC, and we have F flags instead of C flags. Everything else looks the same. Let's run it. Seemed to work. And it runs and gives exactly the identical output to our Fortran 77 program. So there it is. You can compile Fortran programs on your Unix system, assuming you install G-Fortran and any modern Debian, Ubuntu, SUSE, Fedora, Red Hat Enterprise Linux server. They all have Fortran available as G-Fortran. You might have to install it. So, that's it for this video. Please come back for our next video, and we'll get back to the Git version control system, but I thought we all needed a break, and it would be fun to learn how to compile all those scientific programs written in Fortran. Thank you for listening.